Okay, we are now just going to say a word or two on statistical significance and p-values just so that we are aware of what they are measuring and how to interpret them or common interpretations of them, and then we'll move on to correlation. So, whenever we're looking to infer something from some sort of data set or statistical analysis, right, we decide in advance what level of confidence, all right, we will accept as persuasive. Meaning, all right, we will gather evidence, all right, and in order to decide if it is statistically significant, we beforehand set some sort of level, some sort of bar of we need it to be this likely that this evidence wouldn't be here by chance in order for us to say it's significant. Okay, so again, typically people decide if an occurrence would happen less than 5% of the time by chance alone, then we declare the evidence is statistically significant. Okay, so we've gathered evidence and we say this shouldn't happen by chance alone 95% of the time or more. Then we say that means it's significant statistically. And we have to talk about this confidence, this idea of confidence, because what we're doing is we're really modeling our world typically, measuring things that have a level of uncertainty and variation. So we have to determine when is evidence significant. All right. So being statistically significant, this is the likelihood that a relationship between two or more variables is caused by something other than random chance. Sort of restating the above. All right, statistical hypothesis testing, all right, that takes different forms, is used to determine whether the result of a data set is statistically significant. All right, so there are different sort of statistical hypothesis testing tests that can be done, and we'll talk about some of them later. We'll look at different methods in some of our articles, but we're mostly focusing on the concepts and translating them to our world. All right, so this testing, whatever statistical tests are being done, typically provide what we call a p-value. All right, and this p-value, p tends to stand for probability. It represents the probability or likelihood that random chance could explain the result. Okay, so if the p-value is very low, it's unlikely that random chance would explain the result. Right? If it's very high, then we say, oh, this is likely just random chance, not a significant event or evidence. Okay, so in general, a p-value of 5% or lower, p less than or equal to 0.05, all right, it's often given in terms of decimal and not percentage, is considered to be statistically significant. Okay, the lower the p-value, the less likely the data is to have occurred by chance. Okay, so let's briefly talk about an example. So this idea of statistical significance is used often in drug trials for pharmaceutical companies. For one reason, to test the drug for effectiveness. All right, what's the likelihood that this result coming from the drug would happen by chance? In other words, not coming from the drug, for example. And it also tells investors and people how successful the company is at releasing new products that are effective. So, for example, Novo Nordisk, a leader in diabetes medication, reported that there was a statistically significant reduction in type 1 diabetes when it tested its new insulin. Right? And the test consisted of a very fairly thorough experimentation process, and they did a statistical analysis and found a p-value of less than 5%. Okay? Meaning that the reduction in diabetes reduction of the diabetes in their testing was not likely due to random chance. All right? Meaning that it was most likely due to its insulin. Now, those are somewhat different things, okay? But it's a statistically significant result, or the evidence is statistically significant. That doesn't prove that the drug itself caused it, but what we're talking about is we're examining that this reduction saying that this reduction in diabetes was not due to random chance. Okay, and so the more we can isolate a variable, the more we can go into the discussion of causation versus correlation, which we'll get to later. Okay, but the key here is we determine that with this low p-value, that this this reduction was not due to random chance. All right, so we have an observed result, right? Reduction in type 1 diabetes, and we have a p-value going along with it. Now, again, depending on your experience with statistics, you could talk about null hypotheses and what their null hypothesis was. Was it a one-tailed or two-tailed experiment or hypothesis? But we're going to save that for another day. So the key thing here I want you to be taking in is p-value. What does this p-value represent? All right. And then the last thing about this is, for now, I want to make a note. This word significance, all right, in everyday usage connotes consequence and noteworthiness. All right, is what I wrote, I believe. Yes. All right. Now, just because you get a low p-value and conclude a difference is statistically significant, that does not mean the difference will automatically be important. So there's a difference between statistical significance and practical significance. Okay? It could be that this difference didn't arise from chance or is unlikely to have arisen from chance. However, that doesn't mean that that difference is practically important. Okay? It's typically has an apostrophe, an unfortunate consequence of just these words being used to describe this method of statistical testing. In other words, this overlap of statistical significance. Right? So, again, to declare practical significance, we're going to need to determine whether the size of the difference is meaningful, and we're going to look into things like that, how to measure that next week.